Okay, hello everyone. Welcome to my presentation. During this speech, I would like to present you and maybe describe a little bit. Maybe it's not a new, but maybe we can call it as alternative approach to infrastructure as code. Yes, it's still infrastructure as code, but for this presentation purpose, I changed it a little bit to infrastructure as configuration, because from my perspective, with this approach, we're able to move a little bit this part of configuration nearer to application. When application is deployed, we will see it during the second part of this presentation, because I have prepared some demo. So yes, it's still some place for failures and mistakes, yeah, as always when we've got demo, but we will see. And before we start, sorry, I want to apologize because of my voice. Yesterday it was nightmare, but today it's a bit better, so I think we can manage it. Okay, about me, I'm Karol Cienkosz. I think that you can just check my LinkedIn profile if you want to ask something, or I don't know, if you've got some great topic to discuss. Just write me a message. About my background, generally I work as cloud architect / cloud engineer. It depends on the project. Of course, cloud architecture, especially if you are talking about GCP. Yeah, of course, infrastructure as code, everything related to Kubernetes clusters. I've got some space for CI/CD pipelines, mostly based on GitLab CI. And what's more, Apache Kafka. I'm a big fan of this solution, of this component, and how we can use it, and how often we can use it to meet some business requirements. Less officially, generally everything and nothing. I've got a beautiful wife and still some free time, free space for new activities in my life. So generally, I'm trying to try as many things as it's only possible. And yeah, I live here in Kraków. Okay, now we've got spring, but during the winter it's easier to show when it's when the Kraków is located. About agenda, of course, each point will be extended, but at the beginning I want to show what is the problem, why I've raised this topic, and why I want to discuss with you about it. What is config connector, how it works, and how to deploy it. Maybe I want to excuse me, I want to compare it to market standard as Terraform. Then Argo CD in a nutshell, because this approach based on GitOps approach. And then I will show you how to mix and merge several tools to introduce this infrastructure as configuration approach. And in this example, we use Helm chart, Argo CD, and previously mentioned config connector. And then there will be, I hope it will be a longer part, it will be demo, and at the end there is summary. Okay, so what is the problem? Especially if we've got Terraform, which is generally, we can say that it's a market standard. It's a stable, which is really important. It's a stable product, and I think most of us use it as daily. So what is the problem? Especially if Terraform is supported by major cloud providers and not only. What's more about Terraform? Generally, when we are planning some, for example, CI/CD pipelines, I think that for most of us, Terraform is the first option, and we know more or less, but generally we know when and how it should be introduced into our pipelines, and how to debug it, and I don't know how to present it, for example, for a business. And community, which is a huge value of this tool. We love this community. If you have any question, or if you want to contribute into some repository, yeah, community is a true value of Terraform. So why we want to reinvent the wheel again? So lead time, because in one of my actual project we've got separated infrastructure team. So generally, if some developer wants to add some new functionality, new feature for their application, they need to, I don't know, raise a ticket. They want to ask us to, I don't know, create some bucket SQL instance. And the problem is that they're still waiting. They're reporting that they are blocked by us, but we've got, I don't know, dozens of similar tasks to do it. And to be honest, after, I don't know, first 5, 10 similar buckets, it's getting boring for us. And everyone is trying to I don't know, skip or just ignoring this kind of task. And generally, it leads to some, maybe not conflicts, but some difficult relations between developers and infrastructure team. Yeah, but what's more, TF code, it does generally if something is written in TF code, it doesn't mean that it shows environment state. For example, from my experience, it's often a situation when you are, for example, on call and you need to react something. It's midnight. And you need to react and you just click it manually. Or, for example, I don't know, your team leader, your someone which is not so experienced with code, then they don't have a time, they just want to fix something. Then they click it using, I don't know, console or even terminal, but then, of course, they just forget about the code and they don't put these changes into repository. And not last one, but the point about Kubernetes. Now Kubernetes is deployed almost everywhere. Everyone is using it. It's a standard. So solutions like Kubernetes operators are becoming maybe the threshold is getting lower, and we don't have to consider Kubernetes as something which should be added additionally, and we should add some extra cost to use this group of solutions like Kubernetes operators. And the last one, not everyone, for example, developer has to know Terraform. Okay, what is config connector? Generally, config connector it's operator, but in GCP, because as I said, I work generally in GCP environment we can install it as add-on. Of course, this kind of installation is pretty easy, but we need to remember that when we use it as add-on, version of config connector is strictly pinned to version of our GKE cluster, which is really important because sometimes when there are some, I don't know, feature flag or there's new resource which has been added with newer version of config connector and it's not supported with our actual version, sometimes we don't want to update our GKE cluster. So in that scenario, it's worth to consider manual option of installation. And in my actual projects, yes, we use manual self-installed option of installation. Okay, generally it's operators. So the core rule is a control loop. We've got this pod which is still observing, and when we add some manifest or when we update some manifest or remove it, this operator just reacts on that change. So it will remove, add, create some resource, or it will change configuration of particular resource. Of course, if it's possible. Later I will show you that we can limit some behavior. For example, sometimes we don't want to remove some resource, even if manifest, which is some kind of recipes of the resource, even if it's removed, we don't want to remove this resource in our environment because, for example, we've got data, and it's really easy to imagine a situation that some resource is removed from Kubernetes accidentally. So yeah, there is a chance to be protected in that scenario. Here during this demo with GCP config connector, but we've got operators for other big cloud providers like AWS, Azure, or for example, we've got Crossplane, which is multi-cloud solution. We've got list of supported GCP resources. It will be shown during the second part. And the last point is just to show how we can configure where our resources will be created. We can set something, we can set like it's default for a particular namespace. So we can, using annotation, we can set some project ID or folder ID. So if we want to point this this project or folder on the resource level, config connector use this annotation from namespace resource. About deletion, as I said, we can add annotation about deletion policy, for example, abandon, and then when we remove manifest from Kubernetes, then config connector just abandon it, and the resource will still exist. There is an option to import some resources into config connector state. There are some mechanisms to avoid conflicts. And what is really important, config connector generally has two modes, namespace and cluster mode. I think that we can describe it that when it's namespace mode, we can use separated service account for each namespace, which allows us to separate permissions, for example, for particular namespaces, project or applications, or in cluster mode, which means that same single service account will be used for each resource. Okay, config connector versus Terraform. I just chosen several categories when I want to compare those tools. So popularity, about Terraform, market standard, mature tool, huge number of integrations, and as I mentioned, supported by major players, which is important because in my previous project, I had a chance just to discuss with, for example, GCP support about their Terraform models, and they were able to help me or suggest me, or they shared me some information that they know that there are some bugs, and they provided me some workarounds about it. About config connector, it's still gaining popularity. Some features are still in beta. And number of supported GCP resources is limited, but as I said, new resources are still adding month by month, and we've got other operators for other cloud providers. GitOps approach, which now is a really loud and important word. About Terraform, we've got this state file. Requires some pipeline or manual action. Someone has to trigger it or configure some pipelines to deploy the state changes. Generally allows you to make some manual changes between pipelines, and we've got this plan output, and I love it. The moment when you see that That's probably if you would deploy those changes, it would be the last day of your job. If you see the number of destroyed resources because someone has introduced some really small changes into a new version of module, but unfortunately it forced replace of most of your resources. With config connector, there is nothing like state file. We've got just our infrastructure state in our code, or mostly in our Git repository. Generally, commit means that change has been introduced. Of course, there is this small delay between our commit and operator will introduce or will try to introduce those changes into our environment. And unfortunately, there is nothing like plan. So if you commit something, you need to assume that those changes have been introduced. So there is now this step when you have a chance to verify those changes and check the possible impact on your environment. Terraform models versus Helm charts. So generally in Terraform we've got these models, but some of them are they have high entry threshold, we can say. They can be relatively complex, and for example, as I said, developers they don't have to understand it. They don't want to care about it. But high availability of models. We've got so many official models from GCP, AWS, Terraform, but also we've got models, for example, to create some resources on Kafka clusters. And me personally, I love that model. I love this provider, and I use it to create almost everything according to my Kafka clusters, and it generally works. I recommend it. About config connector, relatively low entry threshold because we based on YAML files, which are easier to understand. We've got Helm charts, and I will show you later. But with this approach, I think that we definitely can compare Helm charts to Terraform modules. But unfortunately, I haven't found any public available Helm charts which can be used to create some infrastructure in a cloud, for example, in GCP. But me with my colleagues, we have started some open source project, and we are trying to deliver some Helm charts. Then it will be presented. You can use it. As I said, it's public repo, and we are planning to add new charts in next month, weeks. Okay, and probably the last point: TF file versus YAML file. Generally, Terraform TF file, of course, it's well known, and almost everyone from us use it, so we can understand it. But it doesn't mean that developers love it. And here we've got this descriptive approach, config connector. With this approach, we use YAML files, and probably it's easier format to understand. And here we've got descriptive approach to. Okay, now we've got from scratch installation to use Terraform. Of course, we need to provide some service account or user account if we run our Terraform locally. We need to grant some permission to those service accounts, and if we use some CI/CD pipelines, we need to configure it. And I don't know, we have to schedule it something, or we need some, I don't know, tool to trigger those pipelines. And about config connector, here also we need to create this service account for our config connector, and we need to grant some permissions. Unfortunately, as I said, we need to deploy some Kubernetes cluster and everything which is required by Kubernetes, for example, network. And yes, I use Terraform to deploy it. And then we need to install config connector. As I mentioned, we can use add-on mode. So generally, it's just about tick about config connector feature when we are creating it, or we need to use public GitHub repo when files about config connectors are presented. GitHub's here in my demo, I will use Argo. I'm not a big fan of it. Sometimes I use Flux, for example, but here Argo has big advantage, and it's just user interface. So during the presentation, it's easier to show you something what has changed and to, I don't know, synchronize something. But what's more, here I will use app of apps concept. Maybe I will describe it later when we will see it. And what's more, here's the list of features, and at the end, as I said, Argo can be replaced by Flex CD, for example, if you prefer. Okay, infrastructure as configuration. So as I said, we can use Helm charts. Tools like Argo CD or Flux and config connector to build our own infrastructure and to provide some required infrastructure required by our application. And what is really important with that approach, we can easily move this part. We can easily prepare some predefined Helm charts with, for example, default values properly set, of course, with after discussion with, for example, security team. We've got some defaults. We can block some feature flags on Helm chart level. And what is important, we can group some different resources, which together provides them some, I don't know, product. The easiest example is VM instance. We can group compute instance, IP address, some disks, DNS records into one Helm charts, and then based on dependency or umbrella charts, we can add this chart into chart of our application. Argo CD, the goals of it is just to verify if any changes in our repo happened, and then it just deploy our new manifests into our Kubernetes cluster, which is important. Argo CD, as it doesn't use Helm deploy, it just uses Helm to template manifest, and then it uses just kube CTLA apply to create those manifests in our Kubernetes cluster. And at the end, when those manifests occurs on in our Kubernetes, config connector react on it, and as I mentioned, it will update, delete, or add new resource in our infrastructure. Okay, now short intro about demo. Generally, I've got several GCP projects, host projects, which is just to host my network stuff. Then we've got Kubernetes project, and here we've got my Kubernetes clusters and config connector and Argo CD, which are installed in these clusters. And as we can see, here are our config connector manifests. There are external GitHub projects created specially for these demonstrations. Of course, I will show it later. And what is important, it's helm.treeclosure.com repository or Helm Museum, which is used to provide these Helm charts, which describes our infrastructure for config connector. And interesting thing, it's not expensive tool. It's not expensive toy if you want to prepare such environment for yourself, because in my scenario, generally the cluster which I use for this presentation, the cost of it is more or less 10 zloty per day, and it works 24 hours per day. So I think when we use, for example, spots and proper size of VMs, it's a fair price for those environment if you want to try something, and then you can just remove it. I've got Terraform code to create it, so if someone wants to reuse it, just ask me. I will share you the repo. So yeah, that's all about the part with presentation. Now I'm planning to show you demo. Let me check. I've got scenario because I don't want to miss anything. Okay. So at the beginning, I want to connect to my Argo. I need to expose it. And I use post forward because there is no public load balancer to reach it. And now, yeah. Okay, so here we've got our Argo, which is installed in my Kubernetes cluster. And here we can see that we've got application called Argo CD, because this Argo is self-managed. So after I install it, I can introduce some changes just by commit some new code into my repo, and then Argo will configure itself. DevOpsDays, which is let's say virtual app, just created for purposes for today. We can imagine that on that level, we can call it, for example, product. Like I don't know, my background is from financial sector, so we can say that it's, I don't know, cards, credits, payments, or something like this. And under this application, as I said, virtual application, we can group here all applications which together provide us some true value for the business. And here it's another virtual application which is just to group all products which I introduced before. So what I want to do is to add some application under DevOpsDays product, and then we will imagine that our application received new functionality. Developer adds it, and they require some infrastructure from us. And I will show you how we can provide some hand charts, of course, with proper documentation. And in that scenario, this developer will be able to create, for example, this bucket without asking us to do it. Okay, but before we start, I think that it's worth to present GitHub repositories. As I said, previously I have created some GitHub repos, especially for this presentation. Now it's empty, and we can see that under those applications we've got generally nothing. And what's more here, I've mentioned about this repo when we store all hand charts previously prepared by us, me and my colleagues. And here we've got, it's a public repo, everyone can contribute here. And here we've got previously prepared resources or hand charts to create folder, project, bucket, for example. Bucket includes some required policies, and we can assign some permissions using this hand chart. And for example, what's more I can show you. Of course, here we've got some examples of usage of each resource. So here a simple example. Examples how we can use this Helm chart in our scenario, and I don't know how to set proper storage class, how we can add some lifecycle rules if we want to create packet using this particular Helm chart. About GCP, as I said, now we've got nothing. Here we will create in a moment some new projects. My cluster. Here we've got config connector, which is enabled because I use add-on mode. About workload, I've got only resources related to config connector and Argo CD, and probably at the moment that's all. And here I prepared page when there is a list of resources supported by config connector at the moment. And honestly, I think that at the moment it covers, I don't know, 90% of my usage scenarios. That's why I still use Terraform, but it's my first option if I want to create something. Yeah. So my first option is just to check it if it's supported by config connector, and I'm trying to use it if it's only present here. Okay, so let's switch to demo. Here we've got our code, and the first question is if we can see everything. Let's say try with this file. Is it okay, or should I change resolution? Values are not so important. Yeah, it's if you see form of a file, I think it's enough. Okay, so let's back to my repo. So yeah, as I mentioned, we've got our product, which is called DevOpsDays, and we want to create some application under this product. So what is important, because we use Argo, we need to define some app resources. Here I've got previously prepared to make it faster, but I don't want to use everything. Maybe remove it. Okay, so at the beginning we just create pure application with generally just nothing, but I will show that it will be installed. So we've got Abiam. It's a file with manifest just for Argo. So now we can scale it. We've got chart.yaml, and here we see that we just download and use as dependencies chart externally provided charts to deploy this application. And values at the moment, there is nothing, and we don't want to set, I don't know, some limits, requests, liveness probes, or something like this. It's not the goal of this demo. Okay, so let's push it and refresh Argo. We can wait, I don't know, approximately more or less 3 minutes, but don't waste your time. So that's why I trigger it manually. As we can see under our DevOpsDays product, now we've got our application. And here we can see that there is application, and we create service account, some deployment and service, which are included into source Helm chart. But okay, let's imagine that our developer already adds some features. and we need to create some GCP resources which are required by this application. I need to make it faster because we are out of time. So probably I will have to skip a part, but to achieve it, I will create something which is called shared resources applications, and generally it has just resources which can be shared by more than one application, because, for example, we want to show costs of all product, so that's why we want to create all our resources in same product, just because of this billing purposes. So that's why it's called shared resources. And here we've got folder and project config connector handcharts, which are present in previously presented repo. And about the values, here we've got really short configuration, how should be the name of the folder, and projects. Now we've got DevOpsDays demo 100, which should be created under, now this would be standalone project, and here, let's say it will be 200, and it will be created under folder. Okay, and now just refresh, and now it should create shared resources application. We've got it here, and now we can see that we've got folder. Here we've got status. It is status updated by config connector. It's not a part of Argo, and here we can see that it's updating. So we need to wait. This project should be this one, no, but this one, there's a problem with a name. Yeah, I need to, okay, just, I don't want to use this project, so we can skip that one. But here, as I said, it will be created under our folder, so we are waiting until our folder will be created. If yes, config connector will try again to create this folder. So probably it will be created in a minute. Maybe I will use this time to three, 4 minutes? 2 minutes? Okay, I will try. Okay. Okay, here we can see status, which is true. And now here we are able to see our folder and our projects. One is under the DevOpsDays demo folder, and the second one is standalone project. Okay, but as I said, we want to create a bucket. So now we just want to add dependency chart to our application. That's why I said that it will be moved near to the application. And at the same time, I will add some permissions, because previously I was planning to do it separately, but now because of lack of time. So here we just want to add some bucket, and we just want to add some permissions for our application. And what is important, we want to set some values which are previously prepared. Of course, we don't need to use all these values. It's just for this demo. So here is definition of default settings. Of course, there are some defaults in under handchart level, but we can set it here too. And here are buckets. We can create buckets just like that, and then we use default values. Or, of course, we can override some some specific configuration. And what's more, I add to me some permissions to all buckets, because that's how this chart works. And for only single bucket, bucket 2, I'm planning to add object creator for our application. So let's push it, and we will see what happens, and it will be finished of our presentation. Okay, one important thing. We need to add this annotation, which was presented in during the first part, because I want to create everything from this namespace under this dedicated project. So when annotated has been added, just push it, and probably in a minute we will see results and we are done. Just refresh. Hello world this time. Okay, and here we can see that Argo has noticed that we push some commits, and it deployed some new manifest for our config connector. Let's check the first one, which is bucket 1. Here we can see that status is true. As we remember, we have created it under 200. So let's switch the project and verify if everything is created here. Here. Yeah, and here we've got our buckets, and as we can see, the first one and the second one, the first one and the third one are created with defaults, but the second one we just override some configuration, and we enabled, for example, retention. Yeah, so that's all. That's why we can provide some new way to build our infrastructure, and maybe that's why we can allow, for example, developers to use previously created by us hand charts provided by us, tested by us, and they can just use it without this this time of wasted for waiting until someone from infrastructure time will be able to introduce these changes in behalf of them. That's all. Thank you.